Hello and welcome to another episode of the Dustin and Eric podcast show brought to you by Mimosa Networks. Hi, I'm Dustin.
And I'm Eric.
Today we have a very special episode. We're going to talk about some of Mimosa's new antenna products coming out. And we have a very special guest with us today, Brian Hinman himself.
Hey, gang.
Hi, Brian. Welcome.
Great to be here. Thanks for having me.
So before we start, you want to tell us a little bit about yourself and what you do here?
Well, I'm your boss. No, I'm just kidding. So founded Mimosa. It's been 6.5 years of fun here. And most of the time, I think we've been known as the company that does the great radios. But of late, we've been cranking out a whole bunch of antennas.
So I know I'm excited to talk about this, and I know you're excited to talk about this.
Absolutely.
So we'll move right into it. Today's main course is discussing the N5-45X2 and the N5-45X4.
Beautiful.
So how did you get interested in antenna design?
Well, when I was a small child, I actually built antennas. In fact, like Eric, I used to be a ham radio guy. I'm not active. I haven't been active for 15 years or so, but I used to like ham radio. And in college, I designed antennas. So back at the time, it was all done with pencil and paper, and the reason I liked it was a lot of math involved. But these days, of course, you get supercomputers to do the work, and you can do amazing things with it.
I want to see you design this by hand, not
by hand?
Without a computer.
That would be an exercise.
ESNEC design tool or something.
So what do we have here on the table? What are we looking at?
Oh, we got lots of stuff. We got bits and pieces of antennas, and we got full antennas. As you pointed out, the smaller one of the complete antennas is the X2. This is the two-port design. We run slant 45, so it's plus 45 and minus 45. And then that guy there is essentially the X2 twice as long. And we've got 4 ports, again, plus 45, minus 45. And that one is made specifically to hook up to our A5C access point.
Cool. So this one you can use with pretty much any third-party 5 gigahertz access point.
Exactly. So the reason we did this guy was for that, so that you could have an upgrade if you're on a third-party radio and you want the world's best sector. That's it. But also for people that want a pattern other than 45 degrees, we got a flexible way of using 2 of these. And I know, Eric, you've set up a couple like this, right, where you can stack them on top of each other and turn one way and one the other. Or if you got room on the tower, you can put them next to each other, side by side, and kind of tilt them out a little bit.
Yeah, the initial application was side by side, and it was real easy. I also looked at vertical in the same real estate, stacking vertical. And the only way I could find a place to stack them vertical is if I separated them and put the radio, A5C, right in the middle.
Yeah.
And I chose just to go side by side.
Yep, and another good reason to go side by side for people that are paying for the towers is you pay per lineal foot, right? So you're better off putting them side by side than taking up more space vertically.
Yep.
So the cool thing about our antennas is that they all come with their own LMR cables. They've got the little rubber boots on them to fit over the plugs, and everything looks real nice. But if you wanted to do something where you had 2 antennas stacked on top of each other, you would have to go out and use different LMR cables that were longer to do
Maybe
that.
just a little bit longer. I look at the bend radius on the existing jumpers, and just putting them vertically stacked right on top of each other and running the upper guy's end connector, the jumpers down to the A5C. The bend radius was a little tight, so that's where I just went side by side.
So
we put the cables in because we really want to put the good stuff in there.
Yeah.
It's one of the concerns we've had, and we've seen this with other third-party antennas, is you just sell them the antennas, you get a lower price, and then they go out and get their own stuff. If you go on eBay, even on Amazon sometimes, and you're buying, you think it's good cable, and it's actually just old RG58, and then you're in a really bad spot.
That's horrible above 400 or 500 megahertz.
Yeah.
So, yeah.
So getting back here, you said this is the world's best sector. Is that what you just said?
That's right.
Can I quote you on that?
That's right. We're bringing sectors back.
So what were the technical challenges you were trying to solve when you designed this?
Yeah, so it's probably worth a little bit of background. Sectors have been around forever. They've been used in cellular, and of course we adopted them in the fixed industry a long, long time ago as well. And the reason that they're long and narrow like that is because you take the cover off the inside of it and you got a bunch of stacked antenna elements, and they're being fed in what's called a corporate feed, and it spans out and connects up all those elements. And by going tall in the vertical direction, what you end up doing is you crunch the elevation beam width. So for an 8 or 9 element panel like this one, you got an elevation beam width that's about 9 degrees, and then you got an azimuth that's about 45.
So we got dual feed points here. What did we end up with the gain?
So as a result of that, it's a factor of adjusting your when you look at the amount of elevation and azimuth beam width that you have, we ended up at 19 dBi gain for the 2-port. And then when you beamform it, which like you do with the by 4, then you pick up 3 dB in beamforming, so you go from 19 up to 22. So that's what you end up with.
So what's our front to back ratio on this?
Well, the front to back ratio, first of all, just to describe what that is for folks that don't know, the front to back ratio is what's your antenna gain in this direction off the panel relative to what's the absolute antenna gain in the other direction. And this was an important part of the design process. We were trying to get that down as much as we possibly could, and surprised ourselves a little bit because the simulations only give you a certain degree of accuracy. Then you get to go out on the range and actually measure the thing. And we were kind of blown away. We're at 43 dB front to back ratio, which is more than you see in the horns that are out there today. So we were striving to be as good as the horns are in terms of your front to side, front to back ratio, and much higher gain. But in fact, we blew both away. We're substantially higher in gain, and we're also better in front to back ratio than the horns.
So, fantastic in the sector industry.
Yeah, completely. So, and a lot of the reason, people that are listening to this, a lot of people are very experienced, have been doing this stuff for a while, have adopted the horns for really good reason, which is we don't live in a world that's dominated by KTB noise anymore. We're dealing with interference, and it's that way everywhere. Whether you're on a tower and you're interfering with yourself, interfering with other operators, or on the subscriber side, you've got a whole bunch of 5 gigahertz stuff coming from inside of the house. That's just a matter of fact. And so reducing the side lobes is what drove the push towards going to horns. And then the other thing, of course, is people are running narrower and narrower sectors. That we completely understand. So, but what you give up by that is you're giving up a whole bunch of gain, because most of the horns that are out there, and there are some that aren't, that are asymmetric, but most of the horns, like this one here, it's a symmetric horn. It's physically symmetric, and as a result, in the far field, you get a symmetric pattern. And so it's maybe 30 degrees wide this way, but it means you're 30 degrees wide in vertical, which is way bigger than you want, right?
So we've got you may have, if you're like this, you may have noise. You have noise up here, noise here, depending on where that's at in the real estate on the tower.
Exactly.
You could be just getting
exactly, and you kind of look at it each way. On the receive side, you're picking up noise from places you don't want it, and on the transmit side, you're blowing power where you don't want it. And so that's where we looked at this problem and we said, come on, guys, you got to be able to get both. We want the pattern of the sector because that's going to get you your gain you want.
You want to focus the energy.
Put the energy where you know you want it. And so 45 degrees wide in azimuth and plus or minus 4.5 degrees or so in elevation is enough to fit all your houses and your subscribers within that. You want to do that, but at the same time, you want that great side lobe projection you get from a horn. In fact, since I'm holding the thing up, these horns, they have these circular rings on the inside of them. And those rings are called choke rings. And it's like a speed bump, it keeps the signal from coming over that edge. And so that's how you end up getting this great side lobe projection. So in effect, that's what we wanted to do, but do that in something that's more kind of long and narrow. And that's why these things look the way they do. It's like a little speed bump on the side, which is that choke.
But again, look at on that horn. Look at the energy. Like you said, it's all
It's going everywhere,
and
right?
It's going everywhere.
So you want to do something like that, but you want it to put the pattern where you want it.
Can you explain about the physical design there?
Yeah, it's kind of it's a funky looking shape, isn't it? It's got all kinds of twists and turns to it. So the antenna PCB is placed down in here, and there's a bunch of antenna elements. There's 9 of them that are in there, and then it's a kind of like a funnel, like a horn would be, and then the choke in our case is up here on the top, and we start out this design with something that's roughly in the ballpark, like the pencil design that somebody would do. That's your starting point. And then we do what are called genetic optimizations. So we have 100 parameters, for example, and you're optimizing those all towards the goal of doing 2 things. You're trying to maximize your gain, and you're trying to minimize your side lobes.
Look at your Smith charts and whatever else.
Your antenna gain. The match, of course, matters too. You want the match to be good, but you want your forward gain to be as high as possible and even as possible over your pattern, in this case 45 degrees. And then once you come off your 45 degrees, you want that thing to drop off nice and smooth and keep on going down, and you want to knock that side lobes down as far as possible. And then what you're doing on the computer is you're taking the 100 parameters for all the shapes and sizes of things, and you just sit there and you turn the knobs a little bit and you keep running the simulation over and over again until you get the absolutely best conclusion. And so that requires a pretty powerful computer to make that happen.
Yep. And then you took it out to the field and said, hey, let's measure this
And that-
thing. Let's see where it's at a meter, at X.
And that's the validation that you actually got what you think you got.
Okay.
So real quick, I actually have some screenshots here of somebody who replaced some horn antennas with our N5-45, and I'd be more than excited to show you those. So this is before. This is with 30-degree horns, and as you can see, the MCS rates, the data rates on these are pretty low. Along with your PHY rates, they're not that great either. So a lot of these are 4 to 6. You've only got one client here that's a decent MCS rate.
You got one that's all the way up at 9, but the rest of them are down fairly low.
So if we go to the next slide here, this is after installing the N5-45X4. So as you can see, the data rates, the MCS rates there have increased drastically, and the PHY rates for each of those customers have pretty much doubled in speed.
And this is a comparison. This was 2 of the X2 panels compared to 2 horns.
This was a set of horns to an X4.
Okay,
2 horns facing the same direction.
got it. Yeah,
So it's a huge difference.
definitely.
So since we're talking about X2s and X4s, why do we need a 2-port and a 4-port version, and what's the ideal use case for each?
Well, as we were talking about earlier, the 2-port, you can use that with third-party radios. Some people have asked, by the way, could you use the 4-port and hook up 2 third-party radios? Well, if you run them sync, that would work. If they were not running sync for whatever reason or went out of sync, you'd blow it out of the radio out. So they're too close to each other. But the X4 is perfect for people that want a 45-degree pattern, and they're using our A5C, and you want the highest gain that you can get because those things are built together. They're co-aligned. It uses up the least space on the tower, and that's going to get you the 22 dBi a gain. So that's the goal.
Just
for
the
that.
physical dimensions, just for what we've put out there in the field for different third-party sectors, et cetera, it's just slim. You just cut this thing in half or a third as far as the width all the way down. It's just it's like this instead of like this.
Well, and by the way, on that note, I want to point something out because a lot of panels, people are using these like 16-element panels, and people think, oh, I want to get the highest gain I can get. So if I get one of the 16-element panels that are about the size of the X4, I'm going to get up to 20 dBi a gain. The problem with those panels, and those are the 2-port ones I'm talking about, the problem with those panels is your elevation beam width is only like 2.5 degrees, 2 degrees plus and minus. And you know how that goes. And then you miss a lot of your houses. You can't get your subscribers all in that pattern.
And you take into the electrical down tilt as well, or mechanical.
Yeah,
electrical
and you
down
can
tilt.
easily be way off target. And you think you're buying the antenna that's going to give you the high gain, and in fact, you're worse off. So the difference between what we have in a same length panel is by having 2 separate arrays in there with the 4 ports is our beam width is actually plus and minus 4.5 degrees. And then you're steering within that. So you achieve the same gain you would have with a 16-element, one of the big panels, but you do it in a way that you're going to hit every single subscriber because what happens is the radio is going to beamform up and down for each of your subscribers and be able to pick them up.
So if this is on a water tower at 160 feet or whatever, or it's on a second-floor building, you're good to go almost at a physical, right at the horizon at 0.
Yeah, pretty much
But you get
straight
a
up.
plus 4.5.
Plus and minus 4.5
4.5.
is your 3 dB
So
points.
you're good in the field.
Exactly.
And then as we take this thing up to elevation on a mountaintop at 1,800 feet, we're still decent for the clients that might be down on the ridges down here. You're still good. You might do a little bit of this,
Yeah.
but you got a 2-degree down tilt, so you're already well off. You're like electrically like this now. Yeah.
By the way, there's a good reason just to mention since we're on the down tilt thing. We put 2 degree of down tilt in, so that means when you're straight up,
Yeah.
you're slightly 2 degrees down. One of the reasons why we do this as antenna designers is it makes the back lobe tilted up 2 degrees, your back
yeah.
lobe. So you're getting that little back lobe that sticks back, sticking up in the air. So that's an advantage of doing it. So there's two reasons. One is most of the time it makes sense because you're shooting down a little bit from a higher location, but it also gets the back lobe out of the way of the clients. So that's a benefit of it.
Oh, that's neat.
So because these antennas are 45 degrees and they have superior front-to-back ratios and front-to-side ratios, what kind of different deployments can we do with these on towers?
Well, so I think one of the key thing in the industry, and everybody's trying to do this, is get spectrum reuse. There's not enough spectrum, and today we're at a point where in the industry it's feasible to do what I would call 2x spectrum use by using synchronization. And there are a number of players in the industry. Everybody realizes you got to run sync in order to kind of use the same channel again. So if you run the math on it, you think, if I get a front-to-back ratio of 30 dB and I put a panel this way and I put a panel the other way, it should work okay. I should be able to put them on the same channel and have it work. But, you guys know because you've been out there trying to do this as well. Not necessarily true, because maybe your clients are not perfectly on the pattern, but more importantly, you got some clients that are nearer in and some that are further away, and so that's eating into your margin of what looks like 30 dB is enough front to back ratio. What we're found in practice is it's really not, and you need to get up to that over 40 dB front to back ratio, and that's what we've been able to achieve. And that lets you, even taking into account the realities of the world where you got the near-far problem, somebody that's slightly off the pattern, if you get 40 dB plus front-to-back ratio, you can do 2x spectrum reuse and not take a performance hit.
We're cleaning up the backfield here, the energy going,
Yep.
just like for incoming and outgoing, or TX and RX, yeah.
So I think it's really important to get up to that kind of level of front-to-back ratio so you can get 2x spectrum reuse. But then also, even for people that aren't running sync and trying to get spectrum reuse, the towers are just getting so crazy noisy, and these things it just knock the noise down. And just point out one of the physical things. We got the speed bumps, as I said, the chokes along the side, and this take your side lobes down. One of the other things that we did, and you look at all the other panels that are out there, they don't do it. The end caps, first of all, they're metal. You notice that. They're not plastic like everybody else does. If they're plastic, your signal can get in the end, right? Now, okay, you're sort of hurting yourself there because you got interference coming in the top and the bottom. But then the other thing you'll notice about it is the end caps aren't even straight. They're tilted back by 20 degrees. That's also been optimized through simulation to try to knock down the side lobes that are coming off the panel.
Oh, I see. It's wedged up.
Yeah, you're tilted back a little bit both ways.
That's the reason.
Yeah.
So real quick here, I want to show the X2 in action when you're using a third-party client or third-party access point, and just show you how sleek it looks, and we'll just play the video so you can see.
Oh.
Very clean looking, very low profile.
I recognize that radio.
Mm-hmm.
Got a little elevation, huh? Loop City.
That's beautiful.
It is.
Lots of the panels up there.
We'll just say that when this customer swapped the sectors he was using out to these, he saw a 60% increase in performance across the board. So you can use these again, like we talked about, with any third-party 5 gigahertz access point, or with our own Mimosa A5C.
I like the labels on the back too. All the information. Much of the specifications are right there on that clean label.
Yeah, for you guys that do installs,
I
you
love
like that,
it.
right?
I
It
love
tells
that.
you, like, that you need to know your downtill. If you don't have yourself set up. We got the frequency range on there. And by the way, I should probably mention that.
Yes,
Because
yeah.
Here in the United States, of course, we operate in up to 585, right? But as we've seen in other parts of the world, the people operate on extended frequency ranges. In the United States, for example, we have the 4.9 band. Other parts of the world, a lot of 5.9 and 6.4 that's going on out there.
Mm-hmm.
These are the only panels that have the kind of frequency range that it has. This operates all the way from 4.9 all the way up through 6.4.
Awesome.
I'm sure those people are going to love that. I
Oh,
know
yeah.
people are clamoring for 4.9 and 6.4 because it's so much cleaner. But, all right, well, Eric, tell us a little bit about your installation. I know that you've put 2s and 4s up. How did that go? Was it real easy? Tell us a little bit about your experience.
Yeah, it was good. I got that pair of X2s, put them up, put them in the bucket, clipped it off, and installed them. And like I said, I had a little bit of real estate. I was looking at what's there. We had a couple of other antennas there. And so I found the best spot with the existing jumpers to just go side by side. Brackets went on easy. And so on. Just took a couple of millimeter wrenches out there and just twisted it right on, put it right up.
So they're super light, too.
And they're really light. That was the bonus too. Super light, all metal, great. And then this guy, the X4 N5-45 X4, same thing. It's the same thing, just a little bit longer. So
They use the exact same mounting brackets,
Yeah.
and they're exactly the same spacing. So
I didn't have to go to different tools on it. It was like, oh, this is the this is the same wrenches. This is great.
Like you can start out with
Right.
an X4 or an X2 and swap to the other antenna without having to worry about changing where the mounting brackets are. They're exact same.
Yeah.
You just swap one for the other. So it's made super easy. We
is
appreciate
that?
that.
So that's a good point. And so are these the same distance, right? Are these the same distance right here?
Yeah, it's
Yeah,
exactly
they are.
the same.
Exactly the same
Let's
spacing.
show the camera. So the distance between this and this, and that, it's the same.
Yeah, it had to be because we use the
Okay.
same bracket, and so your degree markings you have to have the spacing the same for the degree markings to be right.
Oh, okay. Yeah, because you got a little play there, and you want the standoff on the primary bracket stand off the same distance on both. Okay. Yep. Gotcha.
All right. Well, we'll go ahead and close down the show here. Super important information here. Really great information. Thank you, Brian, for coming.
Thanks, gentlemen.
Appreciate you taking a few minutes out of your busy schedule to
My
come
pleasure.
in and talk.
I love antennas.
Thanks, Brian. Yeah.
So feel free to start picking these up. I believe they're already on their way to distributors now, or should be there any time. So they're just waiting for you to put in your order and slap some on a tower, because I know you'll love the performance.
All right.
All right, cool. All right, we'll see you next time on our next podcast episode. Thanks for tuning in. Please hit the subscribe or follow button to stay up to date with our latest podcast, which will be available on YouTube, iTunes, Google Play, and SoundCloud.